Well, friends, in the last period, we have seen the chemical reactions of the monohydrate alcohols. Now, in the same chemical reactions, we will discuss that the next chemical reaction of the monohydrate alcohols, and it is the dehydration of alcohols, or it is also elimination reaction also. So, next is the dehydration of alcohols. Dehydration of alcohols, or it is the elimination reaction also. Elimination reaction, particularly in the elimination reaction, it is the beta elimination reaction. So here beta elimination reaction. Now the question arises that what is meant by the dehydration? The meaning of the meaning of the dehydration is a very simple one, and it is means that is the elimination, or it is the removal here. Now here the dehydration of alcohols means here in this reaction the water molecule is removed, and that water molecule is removed from the adjacent carbon atom of the OH hydroxyl group here. So the definition of the dehydration of alcohols is like this here: the removal of water molecule from the two adjacent carbon atoms here. Okay, and here it is also known as the elimination reaction. So elimination is again that the removal here. Now this definition can be tells us in another way also, and it is like this here: when alcohols are heated with the concentrated H2SO4 or the other than the dehydrating agents like the alumina or the potassium hydrogen sulfate or the phosphorus pentoxide, then the water molecule is removed, and it is also known as the elimination of the water molecule or the dehydration of the water molecule. Now in the reaction I have told you that in this reaction that for the dehydration of the alcohols that various that dehydrating agents are used, and in that dehydrating agents one is the concentrated H2SO4 one is the concentrated H2SO4, then second one is that is the Al2O3 alumina, it is also that the strong dehydrating agent, then third is that is the KHSO4 potassium hydrogen sulfate also acts as the strong dehydrating agent, then P2O5 means phosphorus pentoxide, so it is also the strong dehydrating agent, and these dehydrating agents used for the dehydration of the alcohols. But now we will discuss here that the only two dehydrating agents, in that one is the concentrated H2SO4 and another is that is the Al2O3 alumina. Now here first of all I would like to tell you that about that the order of reactivity of this reaction. Now in this reaction that the tertiary alcohols here their order of reactivity is greater than the secondary alcohol, and secondary alcohols their reactivity is greater than the primary alcohols here. So in last period I have told you that such type of that the MCQs may ask in your exam. And what is the MCQ then in this reaction here? The order of reactivity of this reaction towards that the alcohol is dash, and the answer is that is the tertiary alcohols is greater than the secondary alcohol, and secondary alcohol is greater than the primary alcohols here. Okay, so first of all we are going to dehydrate the alcohols by using the concentrated H2SO4, and in this reaction the alcohols are in the liquid phase here. So here first dehydration is the dehydration by using dehydration by using concentrated H2SO4, concentrated H2SO4, and this dehydration is the liquid phase dehydration. Now why this dehydration is known as the liquid phase dehydration? Because in this dehydration, alcohols acts as in a liquid medium. Therefore, it is a liquid phase dehydration here. Okay. Now, I will take here that the one example here. First of all, here we are going to take here CH3CH2OH here, and this CH3CH2OH is nothing but that is the ethyl alcohol here. Okay, so ethyl alcohol. Now, this ethyl alcohol, when it reacts with the 95% concentrated H2SO4 at the 443 Kelvin temperature here, then here the dehydration of the alcohol takes place here, and here what happens here, the OH group that is attached to the carbon atom, that OH carbon atom adjacent is this carbon atom, and from this carbon atom here the hydrogen atom is removed here and to form a water molecule, and remain one is nothing but that is the alkene here. So carbon, and on this carbon here that the two hydrogen atoms are present here, and as the removal of the H2O molecule here, then it will convert into that the carbon-carbon double bond here, and on this carbon here that the two hydrogen atoms are present here, and this is the formula of the ethene or the ethylene here, and the H2O means in dehydration reaction here that the product should be here at the alkene here. Means again I would like to tell here that the meaning of the dehydration of the alcohols here, the way the alcohols reacts with the concentrated H2SO4, then the water molecule is removed and to form alkene are called the dehydration of the alcohols here. Now this is the reaction here. Now when ethyl alcohol reacts with the 95% concentrated H2SO4 at 443 Kelvin temperature to form that is the ethene here. Okay, understood? Now the question arises that here why it is known as the beta elimination reaction. Now of course it is the elimination reaction. Okay, why it is elimination, that already I have told you that because the water molecule is removed, therefore it is the elimination reaction. Okay, but why it is the beta elimination reaction? Now in this reaction, the OH group is attached to the carbon atom. That carbon atom is said to be the alpha carbon atom, and next to the that is the alpha, that is the beta carbon atom, and from the beta carbon atom, the hydrogen atom gets eliminated here. Okay, means the elimination of the hydrogen atom takes place from the beta carbon atom, and therefore it is the beta elimination reaction. Okay, now this is the one example. Now in the same example I would like to take here that the second example. Just I will do here that the some change here. Now in place of this H here, when I take here that the CH3 group, then the CH3, CH2, CH2OH, then it will become that the N-propyl alcohol here, N-propyl alcohol. Now this N-propyl alcohol, when it reacts with the 95% concentrated H2SO4 at the 443 Kelvin temperature, then here that the what will be the change here, that CH3 in place of this CH3 here, CH3 CH double bond CH2, and name of the alkene that is the propene here, propene or the propylene here. So reaction is like this here. When N-propyl alcohol reacts with the 95% concentrated H2SO4 at the 443 Kelvin temperature to form that is the propane. Now, when we take that another example, then that is the CH3CH2 group here, CH3CH2, and next one that is the CH2CH2OH, means it is the N-butyl alcohol here. Now this N-butyl alcohol reacts with the 95% concentrated H2SO4 at 443 Kelvin temperature to form the product is like this here, CH3CH2 here, CH3 CH2 double bond CH3 here, that the CH3 CH2, then CH and double bond CH2 here, and it is the alpha butylene here, alpha butylene, and water molecule gets removed here. So reaction is like this here. When N-butyl alcohol reacts with the 95% concentrated H2SO4 at 443 Kelvin temperature to form that is the alpha butylene. Okay, so this is the reactions of the particular that is the primary alcohols here. So these are the primary alcohols. Now after this come toward that the secondary alcohols here. Secondary alcohols. Now here very important point in this reaction is that here in this reaction tertiary alcohols, secondary alcohols and primary alcohols all alcohols react in this reaction here, or all these alcohols here dehydration takes place here, but these dehydration here that takes place at the different concentrations and at the different temperatures here. So here secondary alcohol I would like to take here that, and in the secondary alcohol especially here that is the secondary propyl alcohol, secondary propyl alcohol, or it is also known as the isopropyl alcohol that I have taken here. Now this isopropyl alcohol reacts with the here 60% concentrated H2SO4, 60% concentrated H2SO4 at the 373 Kelvin temperature, 373 Kelvin temperature. Now here that the elimination takes place, and how the elimination takes place here? Here the OH group that is attached to the carbon atom, to this carbon atom, that the adjacent to this here, that this CH3 or the here this CH3 here, from this CH3 here, when one hydrogen atom gets removed here, for simplicity I would like to change here, in place of this CH3 I have taken here that is CH2H here. So here from this CH2 here hydrogen atom and this OH group gets removed here, and to form here CH3 CH double bond CH2, and name of the alkene is that is the propene here, propene plus H2O. Okay, so reaction is like this here. When secondary propyl alcohol reacts with the 60% concentrated H2SO4 at the 373 Kelvin temperature to form that is the propene. Okay, understood? Now I will take here that one more example of this secondary alcohol here, and the alcohol is here CH3 CH OH CH2 CH3. Now again I will do here that change, in place of that CH2 I just write here that right here H here. Now this secondary butyl alcohol again it reacts with the 60% concentrated H2SO4, 60% concentrated H2SO4 at the 373 Kelvin temperature. Now again here that dehydration with the removal of water molecule from this secondary butyl alcohol here takes place here, and the water molecule is eliminated in this way here, the OH group from this secondary butyl alcohol and the hydrogen atom that is adjacent to the OH carbon atom. Okay, so this water molecule is removed here, and to form here CH3CH double bond CH and the CH3 here. Okay, so the alkene gets obtained here, and name of the alkene is the beta butylene plus H2O here, plus H2O. But one thing here that now in this reaction here there are the two adjacent and the carbon atoms of this OH here. Okay, now in the primary alcohol there should be the only one that is the adjacent carbon atom, this carbon atom. Therefore in this reaction that there is only one that is the product, or only one alkene is formed here. But here in this reaction there are the two adjacent carbon atoms here. Okay, and therefore here the two products or the two alkenes are formed in this reaction. And here just like here that this should be the adjacent carbon atom, like that this should be the adjacent carbon atom. But very important point is here that these two adjacent carbon atoms carries or have the different number of hydrogen atoms. Means here that on this carbon atom here the two hydrogen atoms are present here, and here this adjacent carbon atom contains here that the three hydrogen atoms here. Okay, suppose here that from this that the CH3 here, when one hydrogen atom gets removed here, means again I will change that from this here that the CH3, when the hydrogen atom and this OH2 is removed, then the alkene obtained is the CH2, as the one hydrogen atom gets removed here, then the remaining group is the CH2, and then as the water molecule gets removed here, therefore the single bond gets converted to the double bond here, CH, then CH2 and the CH3 is forming. So it is the beta butylene here. Beta butylene means here when the alkene contains different number of hydrogen atoms that is attached to the carbon atom, and that carbon atom contains the OH hydroxyl group, then it contains that the two different that the products here. So when the two products are obtained in one reaction, then definitely in that reaction one should be the minor and another should be that is the major product. So in this reaction here that this should be the major product, and means beta butylene is the major product, whereas the alpha butylene is the minor product here. Okay, so here the dehydration of alcohol here takes place according to the here Sedgwick's rule, and this Sedgwick's rule already we have seen in the previous topic here. Now what is the Sedgwick's rule here? Sedgwick's rule is related to the particularly that the alcohols, and in the alcohol that are the higher alcohols, or it is applicable for the higher alkyl halides also. Now here what is the Sedgwick's rule? Now according to the Sedgwick's rule, the hydrogen atom is preferentially removed from such carbon atom which carries lower number of hydrogen atom, and that carbon atom is attached or that is adjacent to the carbon atom. Okay, and to form the major products here, and therefore here the major products are like this here. So this is the Sedgwick's rule here, and according to the Sedgwick's rule here, in this reaction beta butylene is the major and the alpha butylene is the beta butylene is the major, and sorry here it should be the alpha butylene, and alpha butylene is the minor product here. Once again I would like to repeat here that the Sedgwick's rule. Now according to the Sedgwick's rule here, the hydrogen atom is preferentially removed from such carbon atom that is adjacent to the OH carbon atom, and to form that is the major product. Therefore in this reaction beta butylene as a major product. Okay, so this is the dehydration of the secondary alcohol. Now here if we see here that this example of the secondary here. Now in this secondary propyl alcohol, again here that the two adjacent carbon atoms are here. Okay, to this CH here, but both these that the carbon atoms contains that the same number of hydrogen atoms. Means here this carbon atom contains that the CH2, and this H is the CH3, and this carbon atom contains also CH3. So here both carbon atoms contain that the equal number of carbon atoms. Therefore here the product obtained is the only one, that is the propane here. But here that this is the higher alcohols here, and therefore it that the in this reaction the two different that the products are obtained here, and in that one is the major, and in that one is that is the minor. Now in this reaction also that the MCQs may ask here. Now suppose that this reaction is given here. The dehydration of that is the secondary butyl alcohol takes place to form that the dash major product or that dash minor product. So in the answer that the beta butylene is the major product and the alpha butylene is the minor product. Or this MCQ may ask in another way also, that the dehydration of the secondary butyl alcohol takes place according to that dash rule. In that there are the four options that okay, and in that correct option is that is the Saint-Chip's rule here. Okay, so in this way the dehydration of the secondary alcohol takes place here, and come toward that the dehydration of the last, that is the tertiary alcohols here. Now in the tertiary alcohols here, tertiary butyl alcohol is an alcohol here. Okay, now see here, tertiary butyl alcohol CS3 C CS3 CS3 and the OH here. It is the tertiary butyl alcohol. Now this tertiary butyl alcohol reacts with here 20% concentrated H2SO4, 20% concentrated H2SO4, and at the 363 Kelvin temperature, and to form here that the product here, and product should be here CS3 double bond CH2 plus H2, and the obtained this alkene is known as the isobutylene. The reaction is like this here. When tertiary butyl alcohol reacts with the 20% concentrated H2SO4 at 363 Kelvin temperature to form the isobutylene. Okay. Now here in this reaction again that the question arises that now why this reaction the different products mean that the major and the minor are not obtained here. Now if you kindly observe this reaction, then you can see that here the OH group is attached to the this carbon atom, this is the tertiary carbon atom, and to this tertiary carbon atom here that the three that the methyl groups attach here, or three carbon atoms are attached here, and all these three carbon atoms contains that the equal number of the hydrogen atoms. Okay, means from any that the this here that the methyl carbon, from any that this here that the carbon atom, or from the this carbon atoms that the hydrogen atom gets removed here, then there should be the CH2 group here, or ultimately that the same that the isobutylene is obtained here. Therefore in this reaction there should be no major and the minor product. Here is the only one isobutylene. So here the reaction is like this here. When tertiary butyl alcohol reacts with the 20% concentrated H2SO4 at 363 Kelvin temperature to form that is the isobutylene. Okay, so in this way we have discussed that the dehydration of alcohols by using concentrated H2SO4, and in this reaction that the alcohols are in the liquid state, therefore the dehydration is known as the liquid phase dehydration here. Okay, and in this reaction you have observed that the order of the reactivity of the alcohols is tertiary alcohols is greater than the secondary alcohols, and the secondary alcohols is greater than the primary alcohols. Now again just I would like to highlight this point here. Now here in the tertiary alcohol here that the concentration should be the here 20% concentration, and the temperature is the 363 Kelvin temperature. Means at the lower concentration and at the lower temperature the tertiary alcohols may dehydrate here, whereas in the secondary alcohol that the temperature is the 373 Kelvin temperature here, and the concentration is the 60%. Okay, and in primary that the concentration is the 95% concentration of the alcohol here, and the temperature is that is the 443 Kelvin temperature here. Okay, so this is the reaction here. And now after this here the next dehydration is that is the dehydration of the alcohols by using that is the alumina. Okay, but now we will stop here.